So let's try one like number 27, K and L. So this one is very similar to those two. And, the temptation is to, hey, let's just find the antiderivative of the top and then divide it by the antiderivative of the bottom. But that is not true, right? You can't just simply find an antiderivative of a fraction of a quotient like this by simply taking the antiderivative of the top and divide it by the antiderivative of the bottom. Think about going in the other direction. If we take the derivative of the antiderivative, we're supposed to get back to what we're integrating. And we know there's a quotient rule, right? Which is pretty complicated, right? It's not simply if you take the derivative, you take the derivative of the top over the derivative of the bottom. So it's quite clear that integration doesn't work that way as well. Okay, so it's much more challenging problem. However, because there's a single monomial, right, term down here, not a binomial or trinomial, I can clearly just use the distributive property and divide each of these three terms up top by this common denominator here, right? Break it up basically by the distributive property. Now 4 times square root of t, I'll write t to what? The 1/2 power, right? And so I've got 16t squared divided by 4 times the square root of t minus 8t, right? So minus 8t, 4 square root of t down here, plus 2 divided by the same thing. And now I can simplify each of these fractions, right? So 16 divided by 4 is 4. To simplify this, I just subtract the exponents, right? 2 minus 1/2 is 3/2. 8 divided by 4 is 2. Here I get t to the first power. 1 minus 1/2 is 1/2. Plus 2/4 is 1/2. And this is divided by 1 divided by t to the 1/2 power. So I'm just going to simply write that as t to the negative 1/2 power. And now I can use the power rule and the constant multiple rule, so to speak, sum difference rules to find the antiderivative. So here we pull the 4 out. Add 1 to 3/2 gives me 5/2 divided by 5/2. Now, when I do this, since dividing by a fraction is the same as multiplying by the reciprocal, right? Dividing by 5/2 is the same as multiplying by 2/5. I'll a lot of times just go right to this form. So over here, t to the 1/2, if I add 1 to 1/2, I get 3/2. And so I'm going to have t to the 3/2 divided by 3/2, or what, multiplied by 2/3. So there's my antiderivative. Same thing here, add 1 to negative 1/2 is positive 1/2. Dividing by 1/2 is the same as multiplying by 2. And I just multiply through by 4. 4 times 2 is 8. Right? Negative 2 times 2 is 4/3. And then 1/2 times 2 is just 1. So there's my answer, and it's fine to write it that way. A lot of times I'll write the t to the 1/2. I'll go ahead and write that as square root of t because that's easy. The t to the 5/2 is the same as either one of these expressions, right? It's the square root of t and then raising it to the 5th power, or raise it to the 5th power and then take the square root. You could write it that way, but if I'm just doing the antiderivative, I would just leave it as t to the 5/2. I mean, it's much simpler. Now, if you're evaluating this like in a definite integral, it's probably helpful to put it in one of these two forms to be able to evaluate then. But for the antiderivative, this is it. This is what I would, I would just give that as my answer. Okay, so that is finding the antiderivative. And so the idea is, again, in finding the antiderivative, if you can simplify what you're integrating first to make finding the antiderivative simpler, then do so. Yeah, simplify always first and then find the antiderivative.